So now that you understand what acceleration is conceptually, we need to also understand how to calculate it. And that'll be true about just about everything we talk about in this class. We need to not only understand the concept, but we need to understand the math for how to analyze it, how to calculate it. And I've already introduced an equation to you at the beginning of all these videos, and that equation looks like this. Acceleration equals delta v. Remember, that means change in velocity divided by time. Remember that word, or that Greek letter delta, just means change. We're going to calculate a lot of changes in different things in this class because in this world things change. To calculate a change in anything, not only change in speed or velocity, we always take the final state and subtract the initial state. So the change in velocity, delta v, equals vf, which is final speed, minus vi, which is initial speed. So if change in velocity is vf minus vi, what we can do is simply take that, substitute it in for delta v, and we get an equation that looks like this. A equals vf minus vi divided by t. Again, important to take note of the case of all of these variables. Notice that they are all lowercase. Notice the parentheses, especially in this equation. That's part of the equation. We have to do vf minus vi first. And then take note of the units. We already knew that velocity, the unit is meters per second. We already knew that seconds is the unit for time, but acceleration is the new one. We've already talked about this in a previous video. The unit for acceleration is meters per second squared. Again, I want to make sure you understand this squared does not mean that you square the acceleration number. You do not square the acceleration. This meters per second squared is simply the unit, just like meters per second is for speed, just like time is just like seconds is for time. But this is not the only equation to analyze acceleration. As a matter of fact, all we need to do is manipulate this equation. We can just algebraically rearrange it, and we get this equation. Vf equals vi plus at. All we had to do is multiply by t on both sides and subtract vi. You don't need to know how to do that. All you need to know is that when you see this equation, it's the same as this one. This is actually equation number 2 on the chart that I'm going to show you in just a minute. This is equation number 3. So you need to remember that number 2 and number 3 is the same equation. We just use them in different circumstances. And then we're not going to go into how we get here, but there are 3 other equations, and we call these the kinematic equations. They're derived in different ways. You don't need to know how they're derived. But all of these equations, each of these 5 equations, are used to analyze, mathematically analyze, accelerated motion, not constant speed. If we have a problem with constant speed, v equals d over t is the equation. But when we have acceleration, we are going to be using one of these equations. Equations 2 through 6 are the ones that we're going to choose from, and we're going to talk about those in a minute. Now, before I show you the equation chart where all of these equations are listed, because you do not have to memorize these, I want to take you through the guess method. Some of you heard this in class, but I want to make sure that we all understand this method of solving problems. It doesn't mean take a wild guess. That's not what this means when we say use the guess method. There's a specific way of solving problems that will help everybody, but most of all, we know that there are some people that really have a difficult time solving mathematical word problems, and that's okay. That's why we do this. So the G, the first step, stands for givens, to simply identify the givens, and the U stands for identify the unknown. And really, this should be just one. It could be 2. This is an identification step. Simply, what does the problem give you and what does it ask for? As a matter of fact, every single time if you come to me or to Miss Savage and you ask a question about a problem and say, hey, I'm having trouble with number 3, can you help me? We are going to respond the exact same way every single time because we want to make sure that you've done this first step to solving the problem. What we're going to say is, what does the problem give you and what does it ask for? That's what this first step does, to make sure that you're identifying what you're given and what the unknown is, what the problem asks you to find. We're going to list them all out. Simply list them and make sure that in this section you label it with the unit and you include the variable. You'll see what I mean by that in a minute. The E step is the next step where that's called the equation. Now, when we say equation, we mean no numbers. Really important. We're going to write the equation down that we're going to use to solve the problem. but no numbers yet. The numbers come in the last two steps where we substitute numbers into that equation or into the formula. No units are needed here. We need units and variables here because we just need to identify the information we have. Once we come down here, we're actually just doing math. The units don't come into the math. And then we're going to solve it using algebra. All right, so let's go ahead and get started. I want you to pause the video for a minute, and if you have a printer handy, it would be great to print these problems. If you don't, it's okay. The main reason why I like to print them is I like to actually diagram the problem, but it's not 100% necessary. So these problems are linked. This page is linked in Canvas underneath this video. And you can go grab that there. So we're going to work through these problems, but I also want to show you something else that's linked in there that you really, really want to print out, and that's this equation sheet. It would be very helpful to have a physical copy of this. It'll always be available to you. You never have to memorize these equations. Notice equation number 1 is the one that we've already discussed. That's our constant speed equation, V equals d over t. And then the ones that we're dealing with today are equations 2 through 6. These are what we refer to as the acceleration or kinematic equations. When we have a problem involving acceleration, these are the equations that we're going to choose from to solve the problem. Now we're going to talk about how to choose the equations because it can't just randomly pick one. We have to pick certain ones based on the problems that we're given, and we'll talk about that. But I also want to remind you that equation 2 and equation 3 are the same equation. We'll just pick when to use them. Okay, so we're going to refer to this chart. I want you to keep that handy, and we're going to look at these practice problems. And you also need a calculator. You also need a calculator in this.